Alright, this video is a general review of matter. So we've been talking about matter for the last couple days, so I'm going to review the key points you need to have for the test. First of all, matter, the definition of matter is anything that basically has mass and takes up space. Matter is divided into two categories, pure substances and mixtures. Pure substances basically come into two forms. You're going to have elements, which are basically all atoms of the same element. That's the simplest form, like iron you find on the periodic table. That is going to be an element. A compound, we've talked about compounds. An easier compound to talk about it would be like water or carbon dioxide. What does that mean? It means that hold on, I just did something. Hold on. Water is an example. Carbon dioxide is a compound as well. A compound is two or more elements. If you notice here, I have hydrogen and oxygen. So I have hydrogen and oxygen, and it's in a specific ratio. That's the idea. So when you have a compound, it's in a specific whole number ratio. So I have a carbon here, two oxygens there. That's a definition of a compound. So whenever I have anything in a specific repeating ratio, I know it's a compound. Then we get in the other side of matter. The other side of matter is going to be mixtures. There's two kinds. Homogeneous mixture and heterogeneous mixture. Homogeneous means it's uniform. Uniform means it's the same throughout. You can't really see the parts. A great example would be air. Air is an example. Another example would be salt water. We also refer to homogeneous mixtures as solutions. So whenever you see the term solution, refer back and realize it's the same thing as homogeneous. Air, as an example, chemistry teachers love to talk about as a solution. If you look at the air in the room you're in right now, you can't see the parts of it because it's all uniformly distributed. Heterogeneous means you can see the parts. Blood, chocolate chip cookie, Italian salad dressing, all those things would be heterogeneous mixtures. You can see the different parts of the components. When we start talking about solids, liquids, and gases, this represents solids right here because if you notice the molecules are very tightly packed in fixed positions. That's a solid. A liquid, the molecules are close together, if you notice here, but there's space between them. Because the key difference between a solid, liquid, or a gas is the amount of space. As you go from a solid to a, okay, so these are liquid molecules right here. There's space in between each of them. So but they're pretty close together. That's what makes it a liquid. Gases, notice how there's large amounts of space. So one key thing is the difference between a liquid and a gas is, it's supposed to be a G, it's a regular looking G, is the amount of space between them. Also the amount of kinetic energy. Gases have more kinetic energy than liquids. Liquids have more kinetic energy than solids. Key things we also talked about are chemical properties. Chemical properties, you have to change the composition of the matter. You have to look for keywords like burn. Whenever you see the word react, it's going to be a chemical reaction. Ferment, decompose. All those things basically require you to change the matter into something else. So it gets rearranged in a chemical reaction and you get something different. Physical properties are observed and measured without changing the composition. Color, hardness, melting point, boiling point. Remember the phase changes. These four phase changes: freezing, melting, condensing, and boiling. If you notice, you have one red and two gray. They're all the same. They never change. The only thing that changes is the distance between them and how much energy they have. So the key thing you have to remember for a chemistry test on matter is any phase change is always going to be a physical property. So all these are physical properties. Got to make sure you know that because they're all the same. It's still one red, two gray, one red, two gray, one red, two gray. They're just tightly packed. That's the only difference. So when we talk about physical and chemical properties, blue color, physical property because I can observe it without changing it. Density is a physical property. Flammability, the ability to burn, that's going to be a chemical property. Solubility is the same thing as dissolving. So when you dissolve like salt water, dissolving is a physical property because you can always get it back. Notice the word reacts right there. Reacts is going to talk to you about a chemical reaction. That's what you're talking about. Combustion, burning, same thing. Chemical reaction. Sour taste can be observed by tasting something without changing the matter into something else. Melting point. Well, we just talked about that. If you go melting right here, melting is going from a solid to a liquid, right? That is a physical property, so we're going to mark that off. There's my keyword right there, reacts. Chemical property, another keyword, reacts. Hardness is a physical property. I can test how hard something is without changing it into something else. And then finally, boiling point. We go back to our phases again. Boiling is going from a liquid to a gas. Again, a phase change means it's going to be a physical property. One of the things they ask you to classify as well is the different compounds. Matter, using diagrams. If you notice the matter in this one, let me go to a highlighter here. If you notice the matter here, I have one black and two white put together, two atoms put together. They're different atoms. That's how I know it's a compound. And they're all the same ratio. The reason I know this isn't an element is because an element is only going to be one kind of thing. That's why number 5 over here is definitely an element. Why? You only see one thing there. So that definitely tells you that's an element. This, if you look, is a mixture of an element and a compound. Notice this is the same right here. That makes that an element because there's no difference. No different shapes or no different atoms. This represents a compound. Why? Because it's two different shapes or two different colors. One's shaded, one's not. And the ratio is the same. Same ratio there, 2 to 4, 2 to 4, 2 to 4. So that represents a compound. So the first thing you should always look for is what's an element. An element is just a single type of atom. These are representing elements right here. These are all elements, so this would be considered a mixture of elements. Here, I notice 2 or more elements combined together, same ratio, that's a compound. That represents a compound too because it's the same ratio. So the same ratio with different atoms is always going to be equal to a compound. That's what you want to pay attention to. That's going to be equal to a compound. This is just one single compound. If you notice, it repeats over and over and over. How do I know it's not an element? Because it's not just one kind of shape. That's the trick. So, next thing, you have to be able to distinguish between arrangement of particles in different samples of matter. I know that this is a gas because of the distance between the molecules. Notice the large amount of distance between the molecules here. I know that this is a gas. The definition of a solid is the molecules or atoms are tightly packed. Notice there's barely any space, so this is going to represent a solid. This, they're close, but there's a little bit of space. That's going to represent a liquid on a diagram. Other things you need to be aware of. Intensive. Intensive means that the amount of matter that you have is key in the type of property. So the more you have, the greater, like for example, mass, volume, calories, length. The 3 big ones in chemistry, the 3 extensive properties are listed here. Mass, volume, calories, and then length down here. Oh, let me add length. If you know those 3, pretty much every other property we study in chemistry is intensive. All right, intensive properties. That means it's the type of matter. Really what it means is at an atomic level, how the atoms interact or how close they are to each other, really. So the amount really in chemistry is so small, or it's on such a small scale, amount doesn't really matter. So it's not dependent on the amount, it's how the atoms relate to each other on an atomic level. Examples would be hardness, density, boiling point, melting point. All those things are intensive properties. All right, next thing you need to know, density. Density, first of all, is a physical property. Does not depend on a chemical reaction to be observed. This is the density house you learned about. The way it works is whatever you're solving for, you mark. So if I'm solving for density, that means it's mass divided by volume. If I'm solving for volume, it's mass divided by density. Mass divided into density equals volume. Common units are always going to be mass over volume units. So grams on the top, milliliters on the bottom. Grams on the top, cubic centimeters, or liters if you're talking about gases. So if you look at a problem right here, the first thing I identify is, what is it asking me for? It's asking me for density. So density is going to be equal to mass over volume. So if I notice, I'm given a volume of 22.3 milliliters. So I'm going to go 2.3 milliliters goes on the bottom. I'm going to take the mass, which is 1.97 grams. It's going to go on the top. Paying attention to sig figs, that has 2. Sig figs, that has 3. My answer is going. So then basically you divide this into the other and express it in 2 significant figures. Easy enough once you do the setup. If they ask you from a diagram point of view, is it a chemical or physical change? Think about this. The definition of a chemical change is you get something different. It's not the same. So I ask you, do you find this molecule over here? Is it exactly the same? Because if you had 2 gray ones, a black one with 4 on the other side, it would be a physical change. Because all you do when you do a physical change is you separate the distance or bring them either closer or farther together. This is a chemical change. The reason it's represented by a chemical change is because it is a different arrangement. So the arrangement changed, not the space, but the arrangement of the numbers to each other. Notice how this is 1 black, 4 white. Over here, none of them exist. So it is a rearrangement. The arrangement has changed, or a chemical rearrangement. That's the definition of a chemical property. What's happening here is a phase change. That represents a solid. They're tight, closely packed together. Then what happens is you're adding some energy. So you're going from a solid to a liquid. Notice they're still fairly close together, but there's space. That represents a physical property, because before and after, they're pretty much still the same. They haven't changed. All that's happened is you've increased the amount of space between them. Other key things you need to remember is filtration. We talked about this. Anytime you want to take a solid from a liquid using a heterogeneous mixture, it's done by particle size. Use filter paper. Put whatever's in there, the solvent with the solute in there, and the residue collects. It's kind of how you make coffee. It's the same idea. Chemistry, we use filtration. The other thing is distillation. If we have things, for example, salt water, one of the things you can do in a lab is you can boil off the water. You can also separate water and alcohol if it's mixed together. So if you look right here, this is an example of distillation. Last key thing we want to focus on is what's called the law of conservation of mass. All that means is in chemical reactions, the mass of the product is always equal to the mass of the reactant you started with. So if I started with a total of 14 grams of reactants, I do a chemical reaction. If I catch all the products, total out the masses would be the same. That's the idea. So law of conservation of mass means that matter is neither created nor destroyed. All it is rearranging. So like if you go back and look at this picture here, you should have the same number. Here's an example of law of conservation of mass. How many gray ones do I have at the start? 2, 4, 6. Look on the other side, I have 1, 2, 3, 4, 5, 6. Wow, that's a bad example. Forget I said that. Let's scratch that. This isn't actually numerically accurate. So that's breaking the law of conservation of matter. That's what not to do. Anyway, never noticed that before. The idea, though, is you have the same number on one side. So if I had started out with 5 black atoms here and 6 black atoms and 6 red atoms on the other side, I would end up with, if I paired these together and formed another compound, let's say, or formed a compound, I would end up like this. If you notice on the one side and the other, 6 red on this side, 6 red on this side. You have 6 black on this side, 6 black on that side. That's the law of conservation of mass. These are key points you need to definitely review. So make sure you review them before the quiz.